Have you ever wished you could just type a question and find the exact moment it was talked about in a video? I'm not talking about searching titles or descriptions, but the actual content inside the video. Well, today, we're going under the hood to see exactly how you build an AI that can do that. Let's dive in. I mean, think about it. For us, trying to find one moment in thousands of hours of video, it's a total needle in a haystack problem. And for a computer, it's been pretty much impossible until now, right? How do you actually teach a machine to find something like the scene where the CEO discusses Q3 strategy when all it sees is just a blur of pixels and a stream of sound? So that's exactly what this explainer is all about. We're going to break down the code of a real production-ready system. We'll look at the actual architecture that takes this massive, messy library of videos and turns it into something smart, something searchable. Okay, so the core of the problem really comes down to this one idea. Video is unstructured data. It's not like a nice clean spreadsheet with neat rows and columns. It's just this jumble of pixels and sounds that traditionally computers have had no idea how to make sense of. And that is the challenge we're going to tackle. All right, so how do you even begin to tackle a mountain of data like that? Well, you need a plan, right? A blueprint for teaching an AI how to both see and listen. We're going to walk through a really clear 5-step process that can take basically any raw video file and turn it into a perfectly searchable moment. So, here's the game plan. First, we're going to ingest the video. Just get it into the system. Then we extract the two most important things, the visual frames and the transcript of what's being said. Now, step 3, this is where the magic happens. We create these searchable ideas from those pieces. After that, it's about organizing them or indexing them in a smart library. And finally, you build an interface so you can actually search through it. Okay, let's get into the real heart of this system now. Because we're not just doing a simple keyword search in a transcript, and we're not just matching images. No. The whole point here is to combine what the AI sees with what it hears to understand the actual, true context of any given moment in that video. Now, the fancy technical term for this is multimodal search. And really, multimodal just means multiple types of data. So we're building a system that can understand the relationship between the visuals on the screen and the words being spoken, all at the exact same time. It's pretty cool. So for every single second of video, you've got to think of it as two parallel streams of information. On one side, you have the video frames themselves, what the AI is seeing. And on the other, you have the audio transcript, what's being said. This project actually uses a powerful AI model called Whisper to get that text, so it's a really accurate transcription of what the AI hears. Okay, so to make sense of these two different streams, you need a couple of specialist AIs. For the visuals, we use a model called Clip. It's absolutely fantastic at looking at an image and just getting what's in it. And then for the text from that transcript, we use another model called BGE, and its whole job is to understand the deeper meaning, the context behind the word. Now, this is where it gets really, really cool. Each of those models, Clip and BGE, turns its input, whether it's an image or a sentence, into a long list of numbers. We call that a vector. By literally fusing these two vectors together, we create one single unified vector. You could almost think of it like a universal translator for ideas. It's this unique mathematical signature that represents both the sight and the sound of that one specific moment. And hey, this isn't some crazy abstract theory. It boils down to just a few simple lines of code. You can see it right here. We grab the image embedding from the Clip model, we get the text embedding from the BGE model, and then, using a common library called NumPy, we just concatenate them. We just stick them together, and boom, they're combined into one super powerful searchable concept. Okay, great. So now we've created millions of these powerful idea vectors. Awesome. But what do you do with them? You can't just toss them into a folder on your desktop, right? We need a really smart system to organize all of this so we can find the exact one we're looking for in, like, milliseconds.
And the solution to that problem is a special kind of database called a vector database. The tool they use in this project is called Pinecone. And honestly, the best way to think about it is like a hyper-intelligent librarian. When you ask it a question, it's not looking for keywords. It's looking for the idea vector that is conceptually or thematically closest to what you asked. It's searching for meaning, not just words.
But it doesn't even stop there. The system uses this really powerful technique called RAG, which stands for Retrieval Augmented Generation. Let's break that down because it sounds complicated, but it's not. First, the vector database retrieves the most relevant video clips. That's the R. Then it hands those clips over to a big language model, in this case, Llama 3, which then generates a nice human-readable answer for you. That's the G. So you don't just get a link to a video, you get an actual answer to your question summarized from the video itself. All right, so we've covered the core AI magic, right? The models, the vectors, the database. But look, a great idea is pretty useless if you don't have some solid engineering to make it work in the real world. So now let's look at the actual code that turns this whole thing from a cool concept into a real usable application. Think of this as the front door to the entire system. They're using a framework called FastAPI. And what it does is wrap up that entire complex search process into one simple little web endpoint, /search. What that means is that literally any other app or website can now tap into this incredible search power just by making a simple web request. It's super elegant.
Of course, a search engine is only as good as its data, right? It has to be up to date, and that's where our tool called Airflow comes into play. This bit of code here sets up an automated job that runs every single day. It goes out, finds any new videos, processes them through that whole pipeline we just talked about, and adds them to the database. It's a complete set-it-and-forget-it system, which is exactly what you want.
And finally, the last step, you have to make this thing available to the world. You have to deploy it. This configuration file here uses a tool called kserve, and it's basically the instruction manual for how the whole application should run on powerful servers up in the cloud. It specifies everything it needs, right down to which powerful GPUs or graphics cards it needs to run the AI models. This is how you go from a project on your laptop to a real, scalable service that can handle tons of users. Okay, so we've walked through the whole build, from the AI models to the deployment code. But the big question is, does it actually work? And, how well does it work? The final piece of this whole puzzle is looking at the numbers to see if all that hard work actually paid off. First up, let's talk about speed. The system has what's called a P95 latency of 180 milliseconds. Now, what that means in plain English is that 95% of the time, you get your answer back in less than a fifth of a second. That's faster than a blink of an eye. It basically feels instantaneous. Okay, so it's crazy fast. But is it accurate? Well, one of the key metrics they measured showed that 91% of the time, the correct video moment was in the top 3 results. So yeah, it's not just fast, it's incredibly accurate too.
And this isn't just some fun science project. As the project's own documentation says, this is the kind of thing you'd build for a perfect interview demo for a media AI lead role. That tells you this is a seriously polished professional system that shows a complete end-to-end grasp of how you build and deploy modern AI in the real world. Look, technology like this is fundamentally changing how we interact with information. We're essentially unlocking this massive library of human knowledge that's been trapped inside video files. And that kind of leaves you with one final big question to think about. If we can now ask questions of any video, what other unsearchable parts of our